Welcome to Part 1, Lesson 1 of Theory. Part 1 deals with pitch. In this lesson, we'll take a brief overview of sound. I'm going to keep it as simple as possible. This is not supposed to be a science lesson. Sound is generated when air is compressed and expanded periodically over time. It is similar to a wave. The top half represents compression and the bottom expansion. A single compression followed by an expansion is called a cycle or vibration. We use time to determine the rate or speed of the vibrations. More specifically, we measure the amount of cycles per second. This is better known as frequency and is measured in hertz. 1,000 hertz means that there are 1,000 cycles or vibrations per second. In musical terms, though, we refer to pitch instead of hertz. The higher the frequency or cycles per second, the higher the pitch of the sound is perceived. Sound can have various degrees of intensity or loudness. This is determined by the amplitude of a sound wave. The greater the amplitude, the louder the sound is perceived. The smaller the amplitude, the softer the sound is perceived. The next aspect of sound that I would like to discuss is the quality of sound. Have you ever wondered what makes a trombone sound different to a human voice? Or what makes a human voice sound different to a piano? Well, that has to do with timbre of the timbre or the tone quality of the sound. Most sound that you hear contains a fundamental frequency, which is the main frequency that you are hearing. But embedded within that frequency are smaller micro frequencies, which you might not pick up with your naked ear. But it is those micro frequencies within that fundamental frequency that determines the sound, the quality or the timbre of that sound. It is the different amplitudes of these combined micro frequencies that determines the quality or tone of the sound. The only sound that is a pure wave with none of these micro frequencies is called a sine wave. These so-called micro frequencies are better known as the harmonic or overtone or partial series. The harmonic series is our guide to what is natural. In other words, there is a relationship between the harmonic series and the music that we listen to. Let's imagine that a sound produces a fundamental frequency of 440 Hertz. The first harmonic would appear at 880 Hertz, which is double the frequency of the fundamental. The second harmonic would have a frequency of about 1,760 Hertz. The fourth harmonic would have a frequency double that of about 3,520. The eighth harmonic has a frequency of about 7,040, which is double that of the fourth harmonic. And the 16th harmonic has a frequency of about 14,080, which is double that of the eighth harmonic. This relationship of doubling frequencies is better known in musical terms as octaves. Once you divide the octave into 12 equal sections or tones, you will have what is better known as the 12-tone equal temper tuning system, which is the basic tuning system we use for today's music. For now, let's just go through a few musical terms to prepare us for the next section. In music, we have what is called octaves, as previously discussed, and the octave is divided into 12 frequencies. Now, in musical terms, these frequencies are better known as notes. Another musical term that you need to be familiar with is half step or semitone. Two notes next to each other with no note in between is referred to as being a semitone or half step apart. Two notes next to each other that have only one note between them is known as a whole step or a full tone. This concludes this session. I hope you guys found it very useful and interesting. And the next section we will be dealing with is pitch notation.